Welcome back. Tonight we are going to drift into one of the deepest mystery of the universe, something invisible, silent and everywhere yet never directly seen. For decades, scientists have searched for it, mapped its influence, built entire theories around it, and still it has remained just out of reach. Dark matter. But what if just recently something changed? What if for the first time we may be getting closer to actually seeing it? So settle in, relax your mind, and let the universe unfold slowly around you as we explore a quiet cosmic mystery, one that stretches across the galaxies and perhaps into the very fabric of reality itself. Imagine looking up at the night sky, far from city lights, where the stars scatter across the darkness like distant lanterns. To the human eye, it feels complete, a vast, glittering map of everything that exists. But what if I told you that everything you can see, every star, every planet, every glowing galaxy, make up less than 5% of the universe? The rest is hidden. Scientists discovered this slowly, not through dramatic breakthroughs, but through quiet inconsistencies. Galaxies were spinning too fast, far too fast to be held together by gravity of visible matter alone. According to everything we understand about physics, they should have torn themselves apart, but they didn't. Something unseen, something massive was holding them together. This invisible presence becomes known as dark matter, not because it is literally dark, but because it doesn't interact with light in any way we can detect. It doesn't glow, it doesn't reflect, it doesn't absorb, it simply exists, silently shaping the universe through gravity. And over time, evidence for dark matter began to accumulate. Galaxies behaved as if they are embedded in massive halos of unseen matter. Cluster of galaxies bent light in ways that could only be explained by hidden mass, a phenomena known as gravitational lensing. Even the large scale structure of universe, the way galaxies form vast cosmic webs, points to something deeper, an invisible scaffold guiding everything into place. And yet, despite all of this, we have never actually seen dark matter. We have seen what it does, but not what it is. For decades, scientists have built detectors deep underground, shielded from cosmic rays, waiting for faintest hint of interaction. They have smashed particles together in powerful accelerators, hoping to create it. They have looked to the skies, searching for subtle signals from deep space, but dark matter has remained until now, perhaps because recently something unusual have begun to emerge, not in a laboratory, but from vast quiet depth of interstellar space. In recent years, astronomers have detected something extraordinary, objects that don't belong to our solar system. These are known as interstellar objects, visitors from beyond the boundary of our sun's influence. They drift through space for millions, perhaps billions of years before briefly passing through our cosmic neighborhood and continuing on their journey into the unknown. The first confirmed interstellar visitor, detected in 2017, was unlike anything we had seen before. It didn't behave like a typical asteroid or comet. Its shape was unusual, elongated, almost artificial in its symmetry, and even more puzzling, it accelerated slightly as it moved away from the sun, without the visible gas trail we would expect from a comet. This subtle acceleration, though small, could not be fully explained at the time. Then came a second interstellar object, more familiar in appearance, yet still carrying secret of its own. It confirmed that these visitors are not rare anomalies, but part of a larger unseen population drifting between the stars. And this is where things begin to deepen. Some scientists have proposed that these interstellar objects may carry clues not just about distant star systems, but about very structure of the universe itself. Because as these objects travel through space, they move through regions dominated by dark matter. And if dark matter interacts even weakly with normal matters, then over immense periods of time, it could leave subtle imprints, tiny changes in motion, faint energy exchange, barely detectable shift that accumulate over millions of years. What if, by studying these interstellar travelers closely enough, we are not just observing ancient debris from other star systems, but also tracing the invisible currents of dark matter itself? It's a quiet idea, but a powerful one. Instead of trying to detect dark matter directly, we observe how it influences objects that have spent eons drifting through its presence. These objects, in a sense, become messengers, carriers of information shaped not only by stars and gravity, but by something far more mysterious. And as our instruments become more precise and our observations more detailed, patterns may begin to emerge, patterns that could finally bring us closer to seeing the unseen. For most of modern science, the search for dark matter has followed a simple idea: if it exists, we should be able to detect it directly. Sensitive detectors buried deep underground wait in silence for the faintest interaction, a tiny collision between a dark matter particle and an ordinary atom. But so far, those signals have not come, and so scientists are beginning to think differently. What if dark matter doesn't interact in the way we expect it? What if it's not made of particles at all, but something more diffuse, more fluid, something that behaves like matter and more like a field separate across space? In this emerging view, detection doesn't come from capturing dark matter, but from observing its influence in new ways. Interstellar objects, with their long, solitary journey, offer a unique opportunity. Unlike planets or asteroids bound to a star, these travelers have moved freely through the galaxy, experiencing environment we can't replicate. If dark matter has even the slightest effect on motion, energy, or structure, then these objects may carry that history within them. These trajectories, their rotations, even their internal composition could reveal subtle anomalies. And as we track more of these visitors, comparing their path with increasing precision, we may begin to notice something unexpected: a pattern, a deviation, a hint that something unseen is shaping their motion in a way that can't be explained by gravity alone. This is not a dramatic discovery, not a sudden revelation. It's quieter than that. It's the slow emergence of evidence, the kind that builds over time until one day it becomes undeniable. And in that moment, we may not see dark matter in the traditional sense, but we may finally understand it in a way we never have before. It's easy to think of dark matter as something distant, abstract, disconnected from everyday life, but in truth, it shapes everything. Without dark matter, galaxies would not have formed the way they did. Stars, planets, even the conditions necessary for life may never have emerged. In a very real sense, dark matter is part of reason we are here at all, and yet it remains one of the greatest mysteries in science. To begin understanding it is to take a step closer to understanding the universe itself, and there's something deeply calming about that because even in a universe filled with unknowns, we are still learning, still exploring, still reaching outward with curiosity and patience. The search for dark matter is not just a scientific pursuit, it's a reflection of something human, a desire to understand what lies beyond what we can see, to find meaning in the invisible. And as we continue this journey through quiet observation, careful measurements, and steady accumulation of knowledge, we move closer not just to answer, but to deeper a sense of connection with the cosmos. And now, as your thoughts begin to slow and the vastness of universe gently settles around you, and you can imagine those interstellar travelers drifting silently between the stars, carrying their quiet secrets through oceans of unseen matter, moving through a universe that is far richer, far deeper than it first appears. And somewhere in that darkness, we are beginning, ever so slowly, to see, not with our eyes, but with understanding. Let that thought rest with you as you drift into sleep, wrapped in the quiet mystery of a universe still waiting to be discovered. Good night.